Hey everyone, it's Mrs. Suderman. Here is the Unit 9 guided review problems. This is probably going to be a long video, so maybe pause it, get some popcorn in your Snuggie, and get ready to be reviewed. Let's get started. So on number 1, we have negative 2 cube root of x plus 5 equal to the cube root of 2x, and we're going to solve for x. So what I'm going to do is cube both sides. So over here I'm going to distribute the cube to both parts. Negative 2 cubed is negative 8. And then the cube root cubed, the cube root and cube will cancel out, so we're left with x plus 5. And on this side we just have 2x. Distribute that negative 8 and we get negative 8x minus 40 equals 2x. Subtract over the 2x and add over the 40, you get negative 10x equals 40. So x equals negative 4. There it is. Alright, let's look at another problem. We have 2x plus 1 raised to the 2/3 power equals 9. To get rid of this 2/3 exponent, multiply by its reciprocal. So we're going to multiply by 3/2, and each side will get that exponent. 2/3 times 3/2 cancels out, so we're left with 2x plus 1. And on this side, the square root of 9, and then cubed. So the square root of 9 is 3, and then 3 cubed is 27. But when we took that square root of 9, remember that that is really positive or negative 3, right? The square root of 9 is positive or negative 3, and then when we cube it, so we'll have 2x plus 1 equals positive or negative 27. Now we can subtract 1. And then we'll get 2x equals negative 1 plus 27 is 26, and then negative 1 minus 27 is negative 28. Divide both sides by 2, you'll get x equals 13, or x equals negative 14. Number 3, 4x to the 3/2 equals 32. I'm going to divide both sides by 4. And then to get rid of that 3/2 exponent, multiply it by 2/3, and do that to the other side exponent as well. So this cancels, we're left with x equals, so this is saying the cube root of 8 squared. The cube root of 8 is 2, and 2 squared is 4. And there's our answer. Next problem. Number 4, the square root of x minus 1 equals x minus 3. I'm solving for x, and I've got this square root here, so I'm going to square both sides. A square root sign and a squared cancel, so you're left with x minus 1. Please be careful right here and don't make the silly mistake of just making that x squared minus 3 squared. That's not okay. This is really x minus 3 times x minus 3. So you have to do FOIL here. So we'll have x squared minus 6x plus 9. I'm going to add the 1 over here, and I'm going to subtract that x right here. So now I have 0 equals x squared minus 7x plus 10. This factors into x minus 5 times x minus 2. So when I set these equal to 0 and solve for x, I'll get 5 and 2. And again, it's really important, especially in a situation like this when we squared something, to always take your answers and plug them back in, because you may end up with an extraneous solution. When I check 2 here, if I plug in 2 to what I started with, I'll have the square root of 2 minus 1, which is 1, equals 2 minus 3. Well, the square root of 1 is 1. 2 minus 3 is negative 1. Not okay. So 2 is not our solution. However, whenever we look at 5, the square root of 5 minus 1, so the square root of 4 equals 5 minus 3. Square root of 4 is 2. 5 minus 3 is 2. Yay, that one works. That one is our answer. Let's look at some inequalities here. Number 5. The square root of x plus 2 is less than or equal to 5. Really, you solve them in the same way that we do equations, except we have an inequality symbol here. So I'm going to square both sides. So the square root and the square cancel. You're left with x plus 2 less than or equal to 5 squared is 25. Subtract 2 from both sides, you get x is less than or equal to 23. But we also have to check that radicand. We don't want to take the square root of a negative number. So we need to make sure that x plus 2 is not negative, so greater than or equal to 0. So then whenever I solve for x here, I'll get x is greater than or equal to negative 2. So between these two things here, I've got negative 2 is less than or equal to x is less than or equal to 23. Number 6, the cube root of 2x plus 4 less than 6. So I'm going to move the 4 over first. I'll subtract 4, so I have the cube root of 2x is less than 2. Now if I cube both sides, the cube root and the cube cancel. I'm left with 2x is less than 2 cubed is 8. So then divide by 2, you get x is less than 4. We don't have to check that the 2x is positive because a cube root can have a negative or a positive answer. So our answer here is just x is less than 4. Okay, number 7, the square root of x plus 3 plus 2 is greater than 4. I'm going to start out by subtracting 2, so we have the cube root of x plus 3 is greater than 2. I'm going to square both sides, so I get x plus 3 is greater than 4. And then I'll subtract the 3, so I get x is greater than 1. But here I have the square root of x plus 3, so I need to make sure that that x plus 3 is not negative, so that way we're not taking the square root of a negative number. So x plus 3 must be greater than or equal to 0. So x must be greater than or equal to negative 3. Now on this one, notice that we're saying x has to be bigger than 1 and it has to be bigger than or equal to negative 3. If you were thinking about this on a number line, here's negative 3, here's 1, we're saying that x needs to be greater than 1, and we're also saying that x needs to be greater than or equal to negative 3. But what we're looking at is really where they overlap, which is right here, which is summarized by x is greater than 1. Since it has to be both greater than 1 and negative 3, being bigger than 1 will cover both of them. So the answer here is x is greater than 1. Okay, let's solve for x here. We have x to the negative 3 equals 1 over 27. I don't like this negative exponent, so to make it positive, I'm going to make this 1 over x to the positive 3. At this point, you can either cross multiply and set it equal, or you consider that these two sides must be equal. So if 1 is equal to 1, then x cubed must be equal to 27. Or you can consider just cross multiplying. 1 times 27 equals 1 times x cubed. Either way, I'll take the cube root of both sides, so I'll get x equals 3. Number 9, I have like bases here being multiplied, and when that happens, I add the exponents. And don't forget that this exponent is really 1. And this is equal to a like base of 10. So if I'm adding these exponents together, And those added together give me 5 to the 1 plus x plus 1 plus 5, and that's equal to 5 to the 10th, then the exponents must be equal. So if 1 plus x plus 1 plus 5 equals 10. So this is x plus 5, 6, 7 equals 10. Therefore, x equals 3. Alright, for number 10, let's graph f of x equals 2 times the square root of negative x plus 3 minus 3. Okay, so for this negative tells us it will be reflected across the y-axis, and we will also have a plus 3, and we'll have a vertical stretch by 2, and we'll have a down 3. But remember, we always must go left and right first, so this plus 3, let's maybe sketch in what our parent function was. Remember that it was at 0, 0, and then at 1, 1, 4, 2, 9, 3. Okay, so there's our parent function. And maybe you've noticed at this point, if you turn your head sideways, you remember with parabolas we did the 1, 3, 5 thing? If we went out 1, we went up 1, then out 1, up 3, out 1, up 5. Well, it's the same way, except here we're going up 1 over 1, up 1 over 3, up 1 over 5. So there's our parent function. But now let's graph our new points. So if we take this point here, this one that was at the origin, so we'll go in this order. We'll go left 3, then we'll reflect over the y-axis, then we'll multiply the y values by 2, and then we'll go down 3. So here's the point on the origin. So we'll go to the left 3, then we'll reflect it across the y-axis. So now instead of being at negative 3, we're at positive 3. Then we'll multiply that by 2, multiply the y value by 2. Well, the y value is 0, so 0 times 2 is just 0, and then we'll go down 3. So there's our first point. Alright, so let's do the next one. Here we were at 1, 1, so we'll go to the left 3, reflect over the y, multiply that y value by 2, and then go down 1, 2, 3. Then we have 4, 2, so go to the left 1, 2, 3, reflect over the y, multiply that by 2, then go down 1, 2. Whoops, I got lost. Let's try that again. Go to the left 1, 2, 3, reflect it over the y, multiply it by 2, then go down 1, 2, 3. There we go. Okay, so now our graph, you can see the shape of it. It's going that direction. Now you could, if you remember that it's been reflected, once you've moved that point that would have been the vertex if it were still an upright parabola, instead of a square root, once you find out where that is, you know it's going towards the left since there was that negative in front of the x, but the y values got multiplied by 2, so instead of going up 1 over 1, up 1 over 3, up 1 over 5, we can go up 2 over 1, up 2 over 3, up 2. Our next point would be at 1, 2, 3, 4, right here. So it's a little bit off there, so it would have gone right there. Let's talk about what the domain is for this graph. It's all of the x values where x is less than or equal to positive 3, and the range is all of the y values where y is greater than or equal to, this point right here has a y value of negative 3. Okay, for number 11, we are going to graph this function f of x, and we're also going to graph its inverse. We'll give the domain and the range for both of these functions, and we'll also find what the function is for the inverse. So let's start out by graphing this function. We have 2 times x minus 3 squared plus 1. Remember, this is in what we call vertex form, where the vertex is at positive 3, positive 1. the 1, 3, 5 here gets multiplied by 2. So instead of going out 1, up 1, we'll go out 1, up 2. Then we'll go out 1, up 1, 2, 3, 4, 5, 6. Same thing on this other side, out 1, up 2. Out 1, up 1, 2, 3, 4, 5, 6. Okay, so there's our function f of x, but we also want to graph the inverse. So we'll take each of these values, the x and the y, we'll switch them and we'll plot those graphs, plot that graph as well. So instead of being at 3, 1, we're going to be at 1, 3. And then you can take each of these values here, instead of being at 2, 3, we could be at 3, 2. Or if you want, you could just think, alright, if I turn my head sideways, then I can go, oh no, look at what happened. Sad teacher. Let's fix that. This graph was at 2, 3. What have I done wrong here? Sorry. This is at 2, 3. It should be at 3, 2. There it is. And this one was at 1, 2, 3, 4, 3, so we should go to 1, 2, 3, 1, 2, 3, 4. I plotted the point in the wrong way. Or you could turn your head sideways and then graph it the same way as what you did before. Out 1, 2, 3, 4, 5, 6. There we go. Sorry for the confusion, but I know you are also very forgiving. Alright, so let's look at the domain and the range of each of these. So for our purple graph here, our f of x, the domain is all real numbers, and the range is all the y values where y is greater than or equal to 1. For our inverse function, the domain is all of the x values where x is greater than or equal to 1. And here, our range is all real numbers. So notice that the range and the domain switched what was from what it was before. But let's also find what the inverse function is for this. So let's find the equation for the inverse function. So if we had started with y equals 2 times x minus 3 squared plus 1. To find the inverse, we'll switch the x and the y. And now we'll solve for y again. So I'm going to subtract 1. Going to divide by 2. Now I need to take the square root of both sides. So the square root of x minus 1 over 2 is plus or minus the square root of x minus 1 over 2 equals y minus 3. But I don't like this square root of 2 happening here in this denominator. So I'm going to multiply by the square root of 2 over the square root of 2. And sorry, I've run out of room, so I'm going to work this direction. So now what I have is the plus or minus square root of the 2 times the x minus 1 is 2x minus 2. The square root of 2 times the square root of 2 is just 2. So I have y minus 3 equals that. So this became that. So then I'm going to add 3 to both sides. So what I'm left with here is y is equal to 3 plus or minus the square root of 2x minus 2 over 2. And there we have it. So I'm going to rewrite that up here. Y equals 3 plus or minus the square root of 2x minus 2 over 2. Sorry, that got a little crowded there for a second. Okay. Okay. All right. Let's move on to something else besides graphing for a little bit here. We've got 7 cubed times 7 to the negative 4th. Whenever we are multiplying like bases, we can add the exponents together. So we have 7 to the 3 plus negative 4 is negative 1. We do not leave negative exponents, so this here is equal to 1 over 7 to the positive 1, or just 1 over 7. Number 13, we have 27 to the negative 1/3. Again, I don't like those negative exponents, so we have 1 over 27 to the 1/3. Remember, 1/3 means we're taking the cube root of that, so we have 1 over the cube root of 27, and that's 3. Number 14, we have 4 to the negative 5th power times 3/5, or I'm sorry, to the power of 3/5. But when we have an exponent to an exponent, we multiply. So the 5's cancel. So what we have now is 4 to the negative 3. Don't like those negative exponents, so we have 1 over 4 cubed, and 4 cubed is 64. There's our answer. And then number 15, negative 32 to the 2/5. That means we're taking the 5th root of negative 32 and then we're going to square it. The 5th root of negative 32 is negative 2. Negative 2 squared is 4. Alright, here's 4 new problems. So number 16, the square root of 2 over the square root of 50. Remember, we can combine that into one big square root. And 2 over 50 is 1 over 25. The square root of 1 is 1. The square root of 25 is 5. Number 17. 3 square roots of 6 minus 4 times the square root of 24. So I probably, here's a little hint, we're probably looking to match this so that we can subtract since we are simplifying. But the square root of 24, I'm trying to think what's the largest perfect square that I can get out of 24. And that's 4, right? Because 24 is 4 times 6. So what we really have here is the square root of 4 is 2. So the square root of 24 is 2 times the square root of 6. So instead of 4 times the square root of 24, we have 4 times 2 square roots of 6. So we have 3 square roots of 6 minus 4 times 2 is 8 square roots of 6. 3 minus 8 is negative 5. So we have negative 5 times the square root of 6. Number 18. Alright, so what we're going to do here, we have 2x to the negative 3/4 over 14x to the negative 2/3. 2 over 14 simplifies to 1 over 7. But I don't like these negative exponents. So I'm going to switch them. I'll move the x to the negative 3/4 down here to make it a positive 3/4. And the negative 2/3 up here to the positive 2/3. Whenever I have like bases being divided, I can subtract the exponents. So I want a common denominator of 12 here. So 2/3 is the same thing as, we got from 3 to 12 by multiplying by 4, so 2 times 4 is 8. And this one would become a 12. 4 times 3 So we have 3 times 3. So now we have x to the 8 over 12 divided by 7x to the 9 over 12. But I'm going to subtract these exponents. So I've got my 1 in my numerator, 7 is on the bottom, but 8 twelfths minus 9 twelfths is negative 1 twelfths. Well, there's that negative exponent again. So what we're going to do is move this part down to the denominator again. So we have 1 over 7x to the 1/12. Number 19, 8 over 125 to the negative 2/3. You could either put this whole thing underneath 1, or it's probably easier to just flip this fraction and do 125 over 8 and then make your exponent positive. So now what we have here is the cube root of this fraction then squared. So the cube root of 125 is 5. The cube root of 8 is 2. But we still need to square it. So 5 squared is 25. 2 squared is 4. So how's everyone doing this evening? Are you still paying attention? I hope you're not too tired. We're getting close to the end. I promise. Okay, number 20. We have the cube root of 80 x to the 7th. So I'm going to figure out what's the largest cube that I can get out of here. So if I'm considering 80, don't be afraid of making a factor tree. 80 divided by 2 is 40, divided by 2, 20 divided by 2 is 10, divided by 2 is 5. But I'm taking cube roots. So I'm looking for a group of 3 things. So there's 3 of these 2's. But there are no other groups of 3, so I'll multiply back together whatever's left. And that will stay. The cube root of 80 is the same thing as the cube root of 2 cubed times 10. So the cube root of 2 cubed is 2. And inside the cube root we'll leave the 10. Then we have that x to the 7th. And in that x to the 7th we have an x cubed and an x to the another x cubed and then an x to the first power. Well, we have 2 of these that we can take out. So here's x squared, and then the one that was left over will stay inside the radical. So there's our simplified answer. Okay, number 21, negative 5 to the 2/5 raised to the 5/3. These exponents, we are wanting to multiply them, and they will partially cancel each other out a little bit. The 5 in the numerator will cancel with the 5 in the denominator, but we'll still be left with the 2/3. And that's actually your answer right there. Number 22, the cube root of 4 times the cube root of 1 over 32. On this one, I would combine these back into one cube root. So we have the cube root of 4 over 32. But 4 over 32 is just 1 over 8. And now it's easy. The cube root of 1 is 1. The cube root of 8 is 2. So that answer is just 1/2. And now, my dear students, we are at the positive, negative, not real portion of our review. For each of these, we're not going to actually evaluate them. We're just going to determine if they're positive, negative, or not real when simplified. On this first one, we have negative 5 to the 5/5 power. 5/3 power. So think of this as the cube root of negative 5 raised to the 5th. So we can take the cube root of a negative number, it'd be negative, and a negative raised to an odd power is also negative. So that's all we need there. On the next one, we have negative 5 to the 2/3. So here, that's like having the cube root of negative 5 squared. The cube root of a negative number is negative, but a negative number squared is positive. Aren't these fun? The next one, we have negative 5 to the 5/8. So that exponent only goes with what it's directly next to, not the negative sign since there are no parentheses. So the negative stays in the front. We have the 8th root of 5 raised to the 5th power. So order of operations, we'll go with the radical first. So the 8th root of 5, so that's an even thing, but the 8th root of 5 is, 8th root of a positive number is positive. A positive raised to the 5th is still positive, but a positive number times that negative is going to be negative. One more, negative 5 to the 3/2, so that 3/2 goes with everything that's in the parentheses, so we have the square root of negative 5 raised to the 3rd. The square root of a negative number is not real, so we don't even have to look at the rest of it because we know that this one is not real. And this is it. We've made it to the end. These are the last 4 examples. So pay attention because you will need to know this. On this, we're looking at the number and type of roots. So we're looking for, are there 1 or 2 real roots, or do we have 2 complex or not real roots whenever these things are simplified? The cube root of negative 7, the cube root of a negative number will just give us one negative number, so this will have 1 for the number, and the type of roots will be one real negative root. On the next one, we have the square root of a positive number. So the square root of a positive number can be a positive or a negative number. So here we'll have 2 real roots. There's going to be 1 positive and 1 negative. The next one we have the 4th root of negative 7. So if we have an even index of a negative number, that means we will have 2 complex, that just means not real, 2 complex roots. So we'll have a plus I and a minus I somewhere. So again, we will have 1 positive and 1 negative. Remember, you cannot have one root that has an I in it without the negative, or one without the other. They always come in pairs. And then the very last example, we have the cube root of a positive number. Cube root of any number is just going to be one number. So here we have 1 real. Here it's going to match this sign, positive root. You've done it. You've made it. If you stuck around this whole time, I am so proud of you. I will see you later. You'll get a review in class, and you can get that online as well. I will see you all later. Let me know if you have any questions. Bye.